This is my first video lesson for Unit 10, Thermodynamics and Kinetics. Take a moment to download the class packet from my website. In this lesson, we'll be interpreting potential energy diagrams. Go to page 3 in the class packet. Learning target. At the end of the lesson, I'll be able to analyze a chemical reaction through a potential energy diagram. Homework be number 1, which is a journal plot based off this lesson. Thermodynamics is defined as the study of energy transfer and its effect on system. Last term, we discussed heat equations, heating and cooling curves, phase diagrams, and calorimetry, which are physical changes. In this PowerPoint, we'll focus on chemical changes, which is endothermic and exothermic reactions and potential energy diagrams. What they both have in common is enthalpy and entropy, which we'll discuss later on in this unit. Potential energy diagrams show how energy changes as a chemical reaction takes place. Here are some examples of potential energy diagrams. What is the label on the x-axis of a potential energy diagram? It is reaction coordinate. A reaction coordinate shows the pathway or the progress of a reaction. You start here, which is the reactants, and as you go from left to right, you make products. What is the label of the y-axis on the potential energy diagram? It is potential energy, which is measured in kilojoules. How we describe the shape of the potential energy diagram? It is a hill or hump shape. Explain why these diagrams are in potential energy diagrams. The first one is a heating curve, which shows physical change. The second one is a ditch, not a hill, and the third one is not a hill as well. Now we're going to label a potential energy diagram. In a potential energy diagram, you always start with the reactants, which is on the left. So this represents the potential energy of the reactants, and the product is on the right of the potential energy diagram, which is over here. Here is the potential energy of the products. Check number 1. What is the potential energy of the reactants and products? The potential energy of the reactants is 40 kilojoules. The potential energy of the products will be 15 kilojoules. Check number 2. Which way is forward reaction? Which way is reverse? So forward is from left to right. Reverse is from right to left. Check number 3. What is the potential energies of the reactants and products for the reverse reaction? In a reverse reaction, everything's backwards. So the potential energy of the reactants will be 15 kilojoules, and the potential energy of the products will be 40 kilojoules. Learning check number 1. Which arrow represents the potential energy of the reactants? Pause the video and resume once completed. Now we're going to label the activated complex. As a reaction proceeds from reactants to products, it must go through a state of the highest energy. So analogy of this is the climax. So the highest point on the potential energy diagram is the activated complex. Check number 4. What is the energy of the activated complex in the potential energy diagram? It is 50 kilojoules. Check number 5. Is it the same for the reverse reaction? Yes. Now we're going to identify the delta H or the heat of reaction enthalpy. Delta H is the amount of energy absorbed or released during a chemical reaction. Here's the equation on how to calculate delta H or the heat of reaction. Delta H is equal to the potential energy of the products minus the potential energy of the reactants. Now we're going to label the delta H on the potential energy diagram. It is between the potential energy of the products and reactants. Check number 6. The delta H for the forward reaction is 15 kilojoules minus 40 kilojoules, which is minus 25 kilojoules. For the reverse reaction, it will be 40 kilojoules minus 15 kilojoules, which is plus 25 kilojoules. Learning check number 2. Which interval on this diagram represents the difference between the potential energy of the products and the potential energy of the reactants? Pause the video and resume as completed. So the question is describing delta H or the heat of reaction. That will be interval 4, choice D. Activation energy, EA, is the minimum amount of energy to start a chemical reaction. It serves as an energy barrier. Here's the equation to calculate the activation energy. It is equal to the activated complex minus the potential energy of the reactants. On the potential energy diagram, it is over here. It is between the activated complex and the potential energy of the reactants. Check number 7. The activation energy for the forward reaction is 50 kilojoules, which is the activated complex, minus 40 kilojoules, which is the potential energy of the reactants, which is 10 kilojoules. For the reverse reaction, it will be 50 kilojoules minus 15 kilojoules, which is 35 kilojoules. Here's a GIF of a potential energy diagram. Learning check number 3. In the diagram below, which letter represents the activation energy for the reverse reaction? Pause the video and resume as completed. For the reverse reaction, it will be D, so choice 4. Here we have two potential energy diagrams. What are the similarities and differences between the two? In the first one, A, the potential energy of the product is greater than the potential energy of the reactants. It is the opposite in B. The potential energy of the reactants is greater than the potential energy of the products. So the delta H in A will be positive, the delta H in B will be negative. In A, we absorb heat overall if you compare the potential energy of the reactants and products. And B, you have the opposite case. You release energy because the potential energy of the products is less than the potential energy of the reactants. So A is considered endothermic because we absorb energy, and B is exothermic because we release energy. Learning check number 4. Which statement correctly describes the energy changes occur in a forward reaction? Pause the video and resume once completed. The activation energy will be 50 minus 40, so it's 10 kilojoules. And since the potential energy of the products is less than that of the reactants, it is exothermic. So the answer is choice B. Check of understanding number 8. How does the energy of the reactants compare to the energy of the products in the diagram of an endothermic reaction? The energy of the reactants will be less than that of the products. Check on understanding number 9. How does the energy of the reactants compare to the energy of the products in a diagram of exothermic reaction? The reactant energy will be more, or the products will be less. Check on understanding number 10. If a forward reaction is endothermic, what is the reverse reaction? It is exothermic. Check on understanding number 11. What if the forward reaction is exothermic? What is the reverse reaction? It will be endothermic. Here we have a potential energy diagram. Compare the solid line with the dotted line. What are the similarities and differences? The solid line represents without a catalyst, and the dotted line represents with a catalyst. A catalyst speeds up the reaction by lowering the activation energy. Notice that the hill is smaller. It provides an alternate pathway for the reaction to occur. Do the catalysts affect the following values? For the PE of reactants, it does not. Notice that the dotted line and the solid line have the same potential energy of the reactants. Same with the products, it does not affect it. How about the heat of the reaction? The heat of reaction will also not be affected by the catalyst since the potential energy of the reactants and products remain the same. Does the catalyst affect whether the reaction is endothermic or exothermic? No, it does not. As we can see from this diagram, adding a catalyst does not change the fact that this reaction is endothermic. Does the catalyst affect the activated complex? Yes, it does. It lowers the activated complex, which lowers the activation energy. To summarize, the potential energy of the reactants and products remains the same when a catalyst is added. The catalyst substance is not used up and can be recovered after the reaction. Check of understanding number 13. A student drew how a catalyst affects the reaction. What is wrong with it? So notice that the potential energy of the reactants is products are lowered, which is incorrect when a catalyst is added. They should be the same as without a catalyst. Learning check number 5. How is a chemical reaction affected by addition of a catalyst? Pause the video and resume as completed. The answer is choice 1. Activation energy will decrease. Learning check number 6. Which reaction will have the lowest activation energy? Pause the video and resume as completed. Based on the potential energy diagram, it is the forward catalyzed reaction. Choice 1. In an endothermic reaction, the potential energy of the products is greater than the potential energy of the reactants. Endothermic reactions must absorb energy from the environment. The sign of delta H for an endothermic reaction will be positive. In an exothermic reaction, the potential energy of the products is less than the potential energy of the reactants. Exothermic reactions must release energy to the environment. The sign of a delta H for an exothermic reaction will be negative. Here's a summary slide of what we talked about today. So this concludes the video lesson. Remember to do the Junipod homework.